Welcome to the course module of Communication Engineering. And in this video, we are going to apply the concept of instantaneous frequency that we learned in the case of frequency modulated signal and phase modulated signal. So here in the problem, which was asked in GATE 2019, this problem actually belongs to the phase modulated signal. So let's go through this problem and try to apply the concept that we have learned during the lecture. So here the baseband signal MT shown in the figure is phase modulated to generate the phase modulated signal phi t equals to cos 2 pi fct plus kmt. The time t on the x-axis in the figure is in milliseconds. If the carrier frequency is fc equals to 50 kilohertz and k equals to 10 pi, then the ratio of the minimum instantaneous frequency to the maximum instantaneous frequency is, okay? So that we have to calculate. We have to calculate this minimum instantaneous frequency to the maximum instantaneous frequency ratio. Okay, so here is the message signal given in the problem. So this is our message signal, and here this time axis t is given in the milliseconds. Okay, so that will be used for generating this particular phase modulated signal phi t equals to cos 2 pi fct plus kmt. Okay, so now we have to find out the minimum instantaneous frequency and maximum instantaneous frequency first. Okay, so in my previous lectures of introduction of angle modulated signal, we learned that the instantaneous frequency will be given by this particular expression FIT equals to 1 upon 2 pi d theta IT by dt, where this theta IT is the instantaneous angle. Okay, so this theta IT will be equals to 2 pi FCT plus kmt. So this is our instantaneous angle of the phase modulated signal, right? So now if you substitute this value of theta IT into this expression can be further written as fc plus k divided by 2 pi into dmt dt, right? So this is the expression that we are going to get for your instantaneous frequency FIT. So now, based on the given waveform of your MT, what we can do is we can write the mathematical form of MT. Okay, so if we write the mathematical expression of this MT in the different duration of your time, let's say if we write the expression for MT in between 0 to 1 millisecond, then this can be written as -1 plus 2000 t. Okay, so you can please verify it can be written in this form. It is very simple to get. Okay, similarly in this duration, right? So because here it is this particular waveform is rising, and here this particular function is decreasing. Okay, so it will be something like a ramp of different slope. Okay, so it is a ramp function, but it is having a different slope, right, in a different time duration. So here again, if you wish to write the MT in this duration in between 1 millisecond to 3 millisecond, the same can also be written in this form. Okay, it will be 2 minus 1000 t in this particular time duration. So now it is, if we wish to calculate what will be the Fi maximum and what will be the Fi minimum value, okay? In that case, it will be depending on the value of this derivative dmt upon dt. So whenever this dmt upon dt is maximum, we are going to get this Fi will be maximum. Okay, when this derivative is equals to minimum value, in that case, we are going to get the minimum instantaneous frequency. So here, obviously, you can, if you differentiate this particular expression, after differentiating this waveform, if you see, this will become a waveform like this. Okay, so this kind of waveform we are going to observe. So it will be something, this kind of waveform in which we are going to get a constant value of 2000 in between 0 to 1 millisecond, and then this value will switch to -1000. Okay, and this will be the fluctuation in different time instant, right? So here you can just make this substitution of dmt upon dt okay, for different time durations, and by that we can calculate what will be the maximum and minimum instantaneous frequency. So let's try to calculate the same thing and substitute fc equals to given value is 15 kilohertz, 50 kilohertz, and k equals to 10 pi. So if you substitute this calculation is very simple to do. So if you substitute this Fi maximum, you are going to get is equals to 60 kilohertz, right? Similarly, we can calculate Fi minimum. That value will be equals to 45 kilohertz. So this is very simple to get, right? So now we can, as per the given problem, we have to find out the ratio of the minimum instantaneous frequency to the maximum instantaneous frequency. So that ratio, if we calculate, then you can see that this Fi minimum was 45 kilohertz and this Fi maximum is 60 kilohertz. So this ratio will come out as 0.75. So basically the answer for this problem is 0.75. So I hope this discussion must be clear. Those who have not watched that particular video in which I have described about this instantaneous frequency concept, okay, please go through that lecture so that you will be able to easily follow this solution. Okay, so hope you have understood this problem. If you have any difficulty, any problem, you will let me know with your comments. Okay, so thank you for watching this video and stay connected with the channel. Thank you.